So you have reduce attack surfaces, you have block attack vectors, you have identify critical assets. Okay, so that's about threat hunting. And I think about the phishing incident response plan. So you have a detailed guide on what the playbook looks like, how you're going to prepare, how you're going to detect and analyze, how you're going to contain, eradicate, and recover. How do you do post-incident handling? So that's what you have detailed in a document. So in another series of videos, I'm going to be doing an exhaustive content on incident response planning. Okay, so that'll be all for threat hunting. So let's move over to attack frameworks. So same thing, we're trying to go over how do you kind of create or model a way that an attacker is going to attack you, learn from that, and create your mitigating strategies. So that's what attack frameworks are about. You have the cyber kill chain. This was developed by Lockheed Martin that describes the stages by which an attack vector or a threat actor progresses in a network intrusion. So remember when I was discussing about the hack process, I was talking about reconnaissance and footprinting, scanning, gaining access, maintaining access, clearing track. So this looks more or less like the 5 hack process. So it starts with reconnaissance. The attacker determines what method to use to complete the phase of the attack. Weaponization. So this is where attacker tries to create some payloads. Take, for instance, you create a Python script that is going to, let's say, extract or exfiltrate data from a PC or a website or something. You kind of weaponize, you create a code. That's why at times you see some movies, you see some files. They are not files or movies in their own sense. They contain some payload. So payload is that aspect of the file or the data that is exploitative, that is going to actually cause the system malfunction. Let's see if we can check a dictionary meaning for payload. So in context of cybersecurity, payload is a piece of malicious code, like I said earlier on, designed to execute a specific action or target. Like in the military, we normally say payload is like your bombs, right? How many payloads was like deployed? So how many bombs, how many cartridges? So in cybersecurity, we say payload is that aspect of the data or the application that is going to actually cause the system malfunction. So in weaponization, you now have a process whereby, like in class, most of our students will try to see how we can create a Python script that's going to actually cause a particular function. And that Python script can be bundled, let's say, in a PDF, or it can be bundled in a file, or it can be embedded in a file that is in a URL, so that upon clicking that particular file, then something can happen. So that aspect of the code that does that is what you call the payload. Or there was sometime a year or two, I was doing a research on what's that research about? I was doing something that has to do with deceptive techniques, right? So deceptive techniques as a way to actually do threat modeling and understanding what attackers do. How did I do that? In your application, you create, normally people will want to right click and view page source, because those are the kind of things you do during footprinting and reconnaissance and maybe basic scanning. So what you want to do is that you want to put in a kind of code or something within the application that is going to lure the attacker, because a regular user will not be inspecting your code, will not be checking up your application, will not be seeing what it is made up of, all of that. A regular user won't do that. Like if I want to start inspecting this application, I want to know how is it built, what programming language was used. Okay, this is a WordPress site, I can see. So that means that I can go back and start doing things like login.php, because this is the administrative login of this particular incident response plan. Okay, good. These guys have tried kind of removed some defaults. Okay, good enough. I'm still able to get, okay. One thing they would have done for this website was to take these defaults off, because it's a vulnerability on its own. Because I can start attempting brute force on this URL, on this. I can start attempting brute force on this particular URL, because this URL is known. So this is a vulnerability on its own, but the vulnerability in terms of between 1 to 10 might just be, let's say, 4, 5, until this can be exploited. So I could go back to the site and start checking, okay, who are the users, and try to see if I can guess the password, or try to reset, try to do social engineering with the owner of that particular account. So in reconnaissance, the attacker typically just determines the method to complete the process. In weaponization, he's trying to create a particular code that can serve as the exploit. Then the next thing is, how am I going to deliver? So you see, that's where a lot of phishing comes in. People sending emails, sending links, and once you click, something happens and the rest. So the attacker identifies how he's going to transmit that code that he has. Then, of course, exploitation, installation, then command and control. Command and control is where you want to now get hold of the PC, because after this stage, you want to now start having remote access. And the only way you can have remote access is if you've actually gotten hold of that particular PC or the website, and you can have continuous and persistent, access to that particular device. It can be a web application, like I said, it can be a network, it can be anything. So the cyber kill chain is a framework, right? So you need to understand that it involves those processes. Okay, there's another framework also, which you call the mutual attack framework. Now, all the years I've actually used the mutual attack to do, they have several platforms. I've used to do common variability exploits, right? To like check for common variability, check for exploits, and all what. So a knowledge base maintained by, we can check that up. So it's just a, so it's a knowledge base maintained by a Mitchell Foundation for listing and explaining specific advisory. So advisory is your attackers. What are their tactics? What are their techniques? And what are their common knowledge or procedures? Because the thing as a cybersecurity analyst, if you can understand how the bad boys do their stuff, then you're able to mitigate such kind of attack. So to get a hacker, you must be one. So that's the idea about this framework. So it's a very detailed and robust, framework that explains to you from the very first stage to the very last stage, depending whether you're in cloud environment, whether you're in network environment, whether you're a web application environment. Now, you see me mentioning most of these areas in tech, because you see, cybersecurity is you being able to actually protect any of this IT infrastructure. So it's not in isolation. That's how we normally say, if a programmer, you're welcome, you could do cybersecurity. If you're a network engineer, you can actually implement, you can actually deploy your skill set to these areas, except you want to do things that are very light, like things in compliance, things in awareness, things in, policy documentation, all of those kind of stuff. So those are very on the lighter notes in terms of cybersecurity. But if you want to actually deploy cybersecurity skills to protect IT infrastructure, then you have to apply it to tech areas like in networks, in cloud, in mobile. These are the areas that these things happen. So you see it: reconnaissance, resource development, initial access, execution, persistent. So this is what the process through which you can have an attack. Their certification, you could take up courses on just the material attack. I think they have a certification, if I'm not wrong. Okay, I think they have something free on Cyberary. Yes, this one, and this one. So fundamental badge training course. To leverage attack. Okay. So understand that you have different frameworks, and these frameworks will help you, because until you can put yourself in the mind of an attacker, then it will be difficult for you to actually mitigate such kind of attack. So you also have the diamond model of intrusion analysis. So this also has core 4 feature is like a diamond. I think I can get it. So it tells us about the advisory, the capability, the infrastructure, and victim. So let me give you an image that explains how this looks like. Let me get something better. Okay, yes, this makes sense. So if I need to explain the diamond model, now it's saying that these are my adversaries, these are the bad guys, these are the attackers. What do? They develop distribute threats. Can't get this word. This is an acronym. And their capabilities, whatever scripts and applications they are going to create, what happens is that they use it to exploit victims. And for that to happen, there must be some sort of infrastructure. There must be some sort of website, tool, application, script, right? And what happens is this infrastructure that gets connected to the victim, right? So the diamond model tries to explain to you how all of this happens, right? And the infrastructure or the script applications or whatever are deployed to actually have some capabilities, because it's only what the infrastructure can do. That's only what it can actually exploit. Now, malware is umbrella word for stuff that causes system malfunction. So they're designed to infiltrate systems. I normally tell my students to go to ChatGPT and type different malwares, the different types of malware, and differentiate them with respect to type, motive, how they operate, disadvantages, and how to mitigate such attacks. So as an assignment, you could get to ChatGPT. If you don't know how to do that, I think maybe Little Google will help, or maybe in this channel later on, I'm going to do a record on that. So differentiate is an assignment. You could drop that in the comment section. Differentiate between different types of malware, and let's know their types, mode of operation, hazard costs, disadvantages, countermeasures. So we can say, how do we counter this stuff? Okay, I think let me see if I can sign into ChatGPT and do this classwork for you. So I'm just going to type this. Okay, now, but this is not how I want my answers to be. Viruses, worms. Okay, so I would prefer these answers to be in a tabular format, right? Differentiate between types of malwares. Let us know their types, mode of operation, hazards, costs, disadvantages, and countermeasures. So, but I'll prefer these answers to be in a tabular format. Okay, I will prefer you give these responses in a tabular format. So I prefer it this way. So you're going to tell me the different types of malware, because if you're taking the CompTIA X+ exams, or you're trying to understand most of these concepts, it makes sense to really get hold of like how this stuff work, right? So you have virus. So how does it operate? It attaches itself and replicate upon execution. It's different from a worm. A worm is a standalone program. It exploits network vulnerability. So it normally spread across your network. So it will typically be a worm where one system is infected, and in the next day or the same hour, you're seeing another system, maybe your intrusion detection system or your antivirus is complaining about another system on the same network. That's a worm. What about a Trojan? How did you differentiate a Trojan? So a Trojan is going to be something that looks like a regular application, a regular software, but it's not. Right? It's not a file, a PDF. Let's say how to become a cybersecurity expert. It's a PDF, but it's not. Or a nice movie in town, but it's not. Right? Then, of course, ransomware, spyware. So you need to study these, be able to differentiate them. I remember some time ago, say 8-9 years ago, I encountered an hardware that took me days to be able to mitigate. Right? So hardware will typically be like an advert. It will just pop up on your browser or pop up in and have a pop-up, and it will just do that advertisement. Try as much as possible to take it off. It is going to be a big hell of effort. So you should be able to differentiate the different types of what's it called? Malware. So malware is just that umbrella word for anything that causes system malfunction. They have different types, they have how they operate. So it's a nice thing for you to study that thoroughly so that you understand how this stuff works. So this is just the explanation for all of that. Okay, there's a very important concept here I need to touch, privilege escalation. So understand that there are different types of privilege escalation. You have horizontal, you have vertical, right? Privilege escalation in cybersecurity. I think when I was discussing what was it called? Gaining access. So privilege escalation is a type of gaining access. So what we're trying to say is that if a hack is going to happen, it's going to be recon first, then enumeration, then you have to exploit one of these 5 areas of hacking. Either you want to run a software that is going to either compromise any of the 5 elements of information security. That's to say confidentiality, integrity, availability, authenticity, and non-repudiation. I've explained those concepts. You want to do what? Because hacking is trying to compromise any of that. In confidentiality, somebody needs to see what is not supposed to see. So in hacking, we're trying to say, how do you use any of this stuff after you've understood where you are, you've gotten some information, which of these methodologies are going to apply and it's going to be possible for it to happen, right? So privilege escalation is one of it, because in privilege escalation, you're trying to say a regular user wants to become an admin. A regular user wants to be another user, or an admin wants to become another admin. So it can be vertical, it can be horizontal. Let me see if I can see an image that's going to help you. Good. So you see a user, an admin, a root, a kernel. Kernel has to be like the core of the hardware of that particular application. So this is very peripheral. So in privilege escalation, people want to move, right? They want to gain access that they are not supposed to have access to, right? So how do you prevent it? Account management, strong password policy, database security, awareness training. Awareness training is very, very key. I think I'm going to be talking about the 3 areas in cybersecurity that if you want to be very good, you need to familiarize yourself with. So like I said, it can be vertical or it can be horizontal. Look at, so this is a vertical. When somebody is coming from here and trying to go up, you call it a vertical privilege escalation. If it's trying to go at the same level, it is what's it called? Horizontal privilege escalation. Look, I think I've talked about logic bump before now. Okay, I think then you have some concept here. Sorry. You have some concepts here that have to do with Easter egg, logic bomb. I've ever explained logic bomb, malicious code that's been inserted inside the program. There is it only when certain conditions are met. They have Easter egg, non-malicious code that when invoked displays an insider joke, hidden message, or secret feature. Then logic bombs and Easter eggs should not be used according to secure coding standards. Then how do you know that you have an infection? So these are some of the things, and most of us are familiar with that. You have strange noises, you have unusual error messages, your display looks strange, things are not how they are supposed to be, your files or hardware drives or application are not, you cannot access them. This is likely a ransomware or a Trojan. Then you have double file extension, things like .text, .exe. So you have new files are created. Like there's a site that was hacked recently, I worked on. So you start seeing things like files that are not there, that are not meant to be there, but they are there. So these are signs, or you can restore a system back to its original state or back to a known good configuration. So these are concepts that you need to familiarize yourself. There are quite a lot of them depending on what you are dealing with. Whether you're on a network or a cloud application or you are on a web mobile application on your what. So these are different signs that shows that you have a malware. And how do you remove, right? You could quarantine, you can install an anti-malware, or you could use an IDS that will detect, or an IPS that will also prevent some of these things from happening. You want to scan your boot sector very, very regularly, right? You want to set up restore points. If you take the Cisco IT I have on my channel, the Cisco IT on the channel, it's majorly hardware stuff, right? So that's why I also employ students that want to do cybersecurity. Get your basics very, very right. So restore has to do with a point in a system that has a series of configurations being set. Like at every time that you install a new software, you configure your system in a particular way, a restore point can be created for that date. So that when anything goes wrong, you can actually go back to that date, because at that date, everything was working fine. So in the future, if something bad happened, you can go back to a restore point. But if it's not enabled, it then means that mess you are in at that particular point, you can't go back, you can't move ahead, and it will not have to do with you resetting the system. Of course, you want to do what's it called? You want to make sure that automatic updates and scans are set up. We've talked about preventing malware. So for each of these stuff that we got here, we also looked at the countermeasures. ChatGPT was able to tell us what the countermeasures are. Are you there? Update your antivirus, avoid untrusted downloads, be cautious with email attachment, very, very cautious, right? Apply patches, use firewalls, right? Isolate infected system, because this is one of the strategies when you are doing incident response, right? You isolate systems that are infected already, right? Then use reputable sources. Don't go download the software because you like it's a download site, right? Don't do that, right? So you have most of these countermeasures. So please, I would love you to do this assignment I gave. If you have questions, you can even drop your answers in the comment section. You have differentiate between different types of malwares, their types, mode of operation, hazard cost, disadvantage, countermeasures, and let the answer be in tabular format. You can ask ChatGPT that question and learn from whatever you're going to see. Training and educating users is very key. If you don't train users, how would they know when somebody, how do they know when they're not supposed to, what's it called? How do they know when they're not supposed to actually open a website? So there are several things you can do to actually ensure that you make sure that you don't have malware, you don't have all of this stuff. Now let's look at preventing malware. So it all depends. We've looked at most of those countermeasures in this guide. So it's something you want to document, something you want to have, something you want to revise, it's something you want to understand. Like I said, your goal is how do you use people? People have to do with the persons That's where social engineering comes in. That's where security awareness comes in. People processes, what are your guidelines? What are your policies? Then technology, how do you use software's applications to actually implement countermeasures? That's the job of a security analyst. When you hear the word use whitelist and blacklist, it then means, take for instance, a simple router. How do you implement a website? How do you implement this? You are saying, okay, particular IP addresses that are susceptible to an attack, or you can pick those IP addresses and blacklist them. If you do web programming, depending on the kind of server that you use, or you tell the web programmers or the developers, they should blacklist these IP addresses, maybe that are logging, or they could code their systems to implement IP addresses that kind of have that attempt. That's why you see some script and plugins implement this even automatically. Once you attempt to log in after a certain number of times, you are blacklisted, or you are kept in a wait list, so that you don't make any other attempt. So these are ways that you can implement all of this. So we have malware exploitation, right? Let's understand some of this concept. Exploit technique. So this describes the specific method by which the malware code infects a target host, right? If we say something like Python scripts, to extract PC system information from a Windows 10, So this can be bundled, implemented now to do what? For a particular target host. So this is a very, very simplistic script. What is it doing? It's going to pick up things like CPU information, memory info, disk information, network info, all of that. And you could modify this script to do quite a lot of things. You can say, okay, I want to bundle this stuff into an executable file. I want to bundle this. Can I bundle this? Can I bundle this into a PDF? There's what we call alternate data stream, right? So alternate data stream helps us to kind of have multiple layers of files within a file. Now you see, this is going to generate, if you work on this, if you generate this, it's going to give you a system.info PDF. If you run it, it's going to have that. I can say, okay, can we have the file export this to a notepad within directory? So that means that I can run the PDF file, but it's going to like extract this and dump it as a text file within the same directory that you have this particular file. Now, I don't want to go into the details of all of these, how to implement it, how to make it work, because of course, understand we're trying to learn cybersecurity, we're trying to learn ethical hacking, we're trying to do things within norms. Of course, there's some script that you should actually implement or clone or deploy in a test environment, not in an enterprise environment. Now, why will I want to say, okay, let us have it as PDF? Because an IDS, intrusion detection system, or an IPS might not allow this particular executable file to run or Python file to run, but typically it's going to allow a PDF file to run. So modern malware uses fileless techniques to avoid detection by signature-based security software. So all PDF files, Word files, executable files, they have their kind of signature. They have their workings. So exploit techniques have to do with how do you evade some of this kind of scans? How does an APT, that's advanced persistent threat, use modern malware to operate? Dropper and downloader. So a dropper is an application that is going to put the exploit into, let's say, a website, a network, a file, sorry, a PC, a mobile app, or a cloud application or something. It then means that when a hack happens, files are actually dropped, and it's those files that are not executed. Download that. So this is called data exfiltration. So this is a guy that is now going to collect the files, like this file we're talking about, the system information or a particular directory. Okay, can this file extract and export the XAMPP folder, assuming this particular target is going to be a developer. So we've done reconnaissance and footprinting. We've done scanning. We now understand that this particular person is a developer. So, and of course, for every developer, if they are on a LAMP stack is Linux, Apache, MySQL, Python. If somebody is doing main stack, that means the person is using maybe MongoDB, let's say Express.js, React, let's say Node.js. So you have main versus me versus LAMP. So this is maybe MongoDB, Express.js, React, Node.js, MongoDB, Express.js, let's say Angular, Node.js. This is Linux, Apache, MySQL, PHP. So depending on the stack of that particular developer, the idea is here is competitive intelligence. So in competitive intelligence, what you're trying to do is you're trying to collect, see what they do, how they do it, and whatever. Or if you're doing this as a pen test work, you want to be able to understand what is possible on this particular server or this particular network and what is not possible. So you're trying to run this particular script. So this is Linux, Apache, MySQL pair. During your basic web programming training, you would have learned most of these things. Main stack is MongoDB, Express.js, React.js, and Node.js. Now, this particular script now, we're saying, okay, can it extract that? And it's saying yes. Okay, let's have the final file as a PDF. So we now have one file that if all things being equal, we can run this file. It's going to export the XAMPP folder of a particular system and dump it maybe within the setup. So you see, one thing is doing dropping, one technique is dropping the file. Another technique is trying to, where is it? Yes, it's trying to drop it. I think it's up here, a moment. Okay, no. So one technique is trying to drop, then another technique is trying to do what? Exfiltrate. Yes, dropper or downloader. Then of course you have maintain access. So the idea is that, can you have continuous access to this particular system that you have extracted data from? Then strengthen access, action on your objectives. What are your other objectives? Then can you conceal? So the idea is that how will you be able to conceal this particular task and this particular stuff you're working on? So this is the explanation here. You have dropper, like I've said, you have downloader, you have shell code, you have code injection. So this is what is now going to try to put in a malicious code with an identification number of a legitimate process. So it's going to be doing either masquerading, dynamic library. This is typically Windows files. Either dynamic DLL, full meaning. Dynamic link library. So file containing code for commonly used program functions on personal computers, basically Windows. So it's the makeup of most what's it called? Most applications. Then living off the land, exploiting techniques that use standard systems, tools, and packages to perform intrusion. Detection of an adversary is more difficult when there is a executing malware code within standard tools and what's it called? Processes. So these are some of the techniques that you need to understand when it comes to how some of these things operate. So the next series of video, we're going to be looking at security application and devices. So if you have questions, don't forget to ask in the comment section. and I'm going to give you answers.